This is how-to videos, momentum. Example 7B, conservation of P, that is momentum, another hit and stick. So Kara is on the softball field. Okay, that's Kara's strangely rectangular shaped glove. She's standing there and the ball is coming in real fast. And she catches the ball, but she's kind of pushed backwards because the ball was coming in so quickly. So she now has the ball, and all of her and the ball are moving backwards. And the question is, how fast are they going backwards? So let's list out our information. Mass of Kara, 75 kilograms. Velocity of Kara initially is 0 because she's just kind of sitting there, right? Or standing, I guess. Velocity of Kara prime is unknown. And the mass of the ball is 0.5 kilograms. The velocity of the ball initially is 35 meters per second. And the final velocity of the ball is unknown. However, we do know that because they are going off together, that this guy is equal to this guy. So I am just going to say that these are V prime, and we'll see why that's so important in just a moment. We use our standard conservation of momentum equation. Momentum of Kara plus momentum of the ball is equal to momentum of Kara prime plus momentum of the ball prime. Now, Kara's initial momentum is 0, so that's kind of handy. And then we have momentum of the ball times the velocity of the ball is equal to momentum of Kara times velocity of Kara prime plus momentum of the ball times the velocity of the ball prime. And remember what we said earlier about this whole thing, V prime thing. So let's just go ahead and get rid of those subscripts. So we really are just talking about V primes on the other side. And you say, well, why would we want to do that? Well, now we can start rearranging things a little bit. We can factor out the V primes, and we have mass of Kara plus mass of the ball times V prime is equal to mass of the ball times velocity of the ball, and that's the initial. I divide through by the stuff in the parenthesis, mass of Kara plus mass of the ball. That goes away, so I'm left with V prime on the right side. Now you might say, oh, looky, I can even cancel out some more because I've got mass of the ball here and mass of the ball here. I'm going to cancel them out. Aha, wait a minute. Remember, there is a plus sign right there, so I cannot simply cancel that out. I actually have to work through all the math. No big deal. 0.5 kilograms times 35 meters per second divided by 75 kilograms plus 0.5. That's 0.5 kilograms. And that is going to be equal to V prime. So tap into my calculator, tap, and I get 0.23 meters per second is my final velocity of Kara holding the ball. So she goes backwards at 0.23 meters per second. Now you might say, oh, she goes backwards. It has to be negative. Well, I suppose, but I never really said any of the other stuff was negative because really it's going in the same direction as the ball was, and they're going in the same direction. So you can choose whatever direction you want as positive or negative. Let's just go ahead and keep it positive. I think that'd be easier. Physics.